everyone! Today we're creating the definitive guide to one of the biggest questions in tech: computer science or computer engineering. Choosing between them can feel like picking a major in the dark, so today we're flipping on the lights.
You know, they sound similar, they both involve computers, but they approach the world from fundamentally different starting points. While they definitely overlap, their priorities and how they solve problems, totally different.
It's a common point of confusion, but we're going to make it crystal clear. Let's frame the core difference this way. Imagine one field starting with the physical reality of atoms and electrons, while the other starts with the abstract power of pure logic.
To get you from confusion to clarity, we have a clear roadmap for this explainer. We'll start with a core concept, apply it to a device you might be wearing right now, dig into the different mindsets, and finish with a simple test to help you figure it all out. Okay, let's dive into this with our first section, the core concept that frames everything, the full stack model. The key here is to stop seeing a computer as just one thing, but as a stack of interconnected layers.
The best way to understand the difference is to visualize a computer as a layer cake. At the very bottom, we have the physical world. This is the domain of computer engineering. We're talking about physics, electronics, voltage, circuits, and the tangible microprocessors that make computation possible in the first place.
Now let's jump all the way to the top of that cake. This is where you have the world of computer science. This is all about abstract logic, software, the apps we use every day. It deals with data, algorithms, and even AI. And right there in the middle, that's the critical overlap, the handshake between the hardware and the software, where both fields meet. This is where you find things like operating systems, firmware, and embedded systems. It's where the OS developers and firmware engineers live. So the crucial point is that one field builds the machine and the other tells that machine what to do. Let's make this tangible with a real-world example. Let's deconstruct a smartwatch. If we take apart a smartwatch, we can see exactly who is responsible for what. The computer engineering student is totally focused on the physical components and their efficiency. The battery sensor, the Bluetooth antenna, making the processor sip power. Meanwhile, the computer science student builds the logic and the experience that run on that hardware. The health tracking algorithm, the logic that syncs your notifications, and the user interface you actually tap. This difference in what they build stems from a difference in how they think. And it's not just about the classes you take. It's about the fundamental type of math and logic you use to solve problems. See, computer engineering operates in a world of continuous and physical math. Think calculus, think physics. You're calculating things like electricity flow, heat dissipation, signal processing. But computer science, that's all about discrete and logical math. It's about proofs, graph theory, probability. You're trying to prove truths and optimize abstract processes, like an algorithm. So are you more interested in the physics of the machine or the logic of the information? This choice has real-world consequences for your career. While both fields are absolutely crucial, the demand for software-focused roles is growing significantly faster, a projected 21% over the next decade. And that's because software continues to innovate across literally every industry. Hardware engineering, on the other hand, is projected to grow by a very steady 5%. But that growth number doesn't tell the whole story. Computer engineering is still a highly compensated and vital field. The median salary back in 2021 was over $128,000 a year. These are the folks responsible for the foundational hardware that powers all that software innovation. Now, let's bring it all back to you. You know, the best way to choose is often to figure out what you don't want to do. So let's do a little litmus test. Let's start with computer science. You should probably pick CS if you hate the idea of soldering irons and oscilloscopes. If the messy, physical limitations of wires and heat just annoy you, and you really don't want to get into low-level languages like assembly, then CS is probably your path. But what if the opposite is true? Well, you should probably pick computer engineering if purely abstract theory with no physical result just leaves you cold. If you hate debugging code that doesn't interact with hardware, or you just want to create something that feels real, something you can actually hold, then CE is probably for you. And this brilliantly illustrates the final choice. Both fields are essential, but they appeal to different problem-solving personalities. From the layer cake model to the smartwatch and the litmus test, we've seen how these two fields, while totally related, are really distinct worlds. This brings us to the final question for you to consider. So, will you architect the physical world or the digital one?